All right, so in the previous video, we had you try to pause and try to find the solutions to this problem. I'm going to try to get those for you. I have them available, but you'll just have to hold on 1 second, so sorry about that. Wasn't as prepared as I could have been. So the decimal answers for those are, I think, and we round to 3 decimals, negative 3.842 and 2.342. So it was like, I think it was the zeros, and also a zero of -1, sorry. So -1 was a zero, that 1, and then probably quadratic formula. I think it was -3 plus or minus 3 root 17 over 4. So hopefully that's good. All right. So what this video is going to kind of talk about is how zeros occur in pairs. We kind of know about the conjugate, at least we've kind of talked about it. So today we're going to kind of explore that in a little more detail. And just bear with me as I get my bearings here. So we want to find a function, a polynomial, but if it has these coefficients, right? It has these 3 zeros, right? We already know a little bit about this polynomial, and we also know that this is a 0. So to keep it quite simple, if 3i is a 0, is a root, I guess, then negative 3i is a root. So the polynomial must have been x minus x plus 1 squared. That's this and this, the two roots there. And then x minus 3i, that's this root, and then x plus 3i. This is a 1, 2, right from here, 3/4 degree polynomial. So that is it. So again, what you're going to do is the conjugate, if one of the zeros is a plus bi, the other zero is a minus bi. If one of the zeros is a minus bi, the other zero is a plus bi. It can get a little confusing because of the whole like changing the sign with the conjugate and changing the sign with the roots and the zeros. So try to realize that those are two different ideas. Okay, the conjugate is one thing where you change the sign, and switching the signs is also a thing we do with the factors turning to zeros. I think you could probably pause the video and give this problem a try. So I'll encourage you to pause the video and give that problem a try. And this one is pretty similar. It's a cubic polynomial, so it's f of x equals, right? And we know 2 and 1 minus I. So 2 is a 0, so that means x minus 2 is a factor. And then x minus 1 minus I is a factor. You see that? It's kind of weird. And then x minus 1 plus I is a factor. So this is potentially the polynomial. But the problem is that we need f of 1 to equal 3. So it's kind of like taking this problem, but now taking another step. So let's just make sure that when we take f of x, which is whatever this multiplies out to, I guess perhaps we should just multiply it out. I'm trying to think if... All right, so I'm picking this back up because it was not going well. What I was trying to do was not working out. So the only thing that I've changed here, and I want to kind of erase this because I basically just failed on this problem. But what I want to say is that we're trying to find this function, but we don't know what number might be here. We know there's not another function. Like we know it's just a constant, I guess you might say, right? A constant. But we don't know exactly what's happening here. And so we're just going to put a, and our goal is kind of a equals question mark. So what is a, right? Now, what's going to make this a lot better is to figure out what this is if you just kind of FOIL it. You'll see a really cool, a very helpful trick. Okay. And then x minus 1, then minus I. Now this is what I kind of missed last time. I want to show you what I'm talking about. What I'm trying to say is that this is actually been reformatted, like shuffled around. There's other ways to get there, but this is going to save you some time. And now when you FOIL this, you actually have x minus 1 squared. This is a difference of squares. Minus I squared, right? Minus I squared. But I squared is negative 1, so it's actually plus 1. So in other words, all of this right here is actually this, okay? Hopefully you can trust me on that, or you can get there. It's kind of like reinventing it to be a difference of squares, and it makes the math way easier. And that's why I had to redo the problem, because I didn't do that first. So now we're here. That's really good. And there's going to be a couple things that are going to happen. We can now, I think, maybe we could multiply this out. I think that's what I want to do. X minus 2 times x squared minus 2x plus 2, I believe. And now what we can do is we can use the f of 1 equals, right? The f of 1 equals. So we can use that f of 1 is 3. So 3 must equal a times, we're going to put 1 in here, negative 1. We're going to put 1 in here. We're going to have 1 minus 2 plus 2. So we'll end up with, I guess, cancel, we'll end up with negative a equals 3. So a equals negative 3. And since a equals negative 3, we can actually put that right here. So f of x is equal to negative 3, and then x minus 2, and then x squared minus 2x plus 2. Now, if they say find a polynomial in standard form, then we have to do one more thing, which is to distribute, and multiply by negative 3. So that'd be negative 3 times, that'd be x cubed minus 2x squared minus 4. I'll just do it sideways. I don't know if you guys have seen the stacking method where you stack them. It's very helpful. I'm sure I'll show it to you at some point. So we'll have negative 3x cubed. This is negative 4 times negative 3, so positive 12x squared, right? And then we have negative 12x. I think I made one mistake here. I think I missed something. Let's just see. I'm going to pause and try to figure it out before I ruin it. Okay, I think I figured it out, because I think when I was here, this should have been a plus 2x right here, the second ribbon. This should have been well, actually a minus. This should have been a plus 2x. That's my mistake. So that gives us 3x cubed. This is negative 4. This is 6 times 3, so that's negative 18x. And then that's going to be plus 12. So we finally got it. So this is what y is equal to. This is the polynomial. And we're sort of working backwards now, using roots to go the other direction to figure out the polynomial. So hopefully that's a good start. Okay, let me get it back. It would be wise for you to try and pause the video and try this problem right here, this checkpoint. So please pause the video and give that a try. In the meantime, I'm going to realize that this is a 0, so that means that this is a factor. X minus this is a factor, and x minus its conjugate is a factor. So I know right now that 1 plus 3i and 1 minus 3i are zeros. And now what I can do is I can kind of like figure out what this is all about, perhaps, before I really do anything else. I could use the rational root theorem too if I want, but let's just see. Now this magic that I did on the last problem, this is actually new to me, but I think it's pretty great. Minus 3i, that's this, and then this is x minus 1, right? And this is now plus 3i. I thought it was fantastic, because that means that this is now x minus 1 squared minus 9i squared, which is x minus 1, move that up for you, x minus 1 squared plus 9. Okay, so that's part of this polynomial. I'm going to make a suggestion here. I don't know exactly how they would handle this, but I think we're in a situation where we need long division now. So we can't divide. We could try rational root theorem, but I think the goal here is to kind of go long division. So we have x squared minus 2x plus 1 plus 9, so that's plus 10. So that's what this is. This is a factor. So what we're going to do is, this is new. We're going to put x to the fourth minus 3x to the third. Now, because this is not a linear factor, we're going to use long division to see what's left once we take out this 0 and this 0. So this is going to be x squared minus 2x plus 10. So this will be x squared. This will be x squared minus 2x cubed plus 10x squared. We're subtracting. Watch out for this. Winds up with negative x cubed minus 4x squared plus 2x. So I think it's just negative x cubed plus 2x squared minus 10x. We are subtracting. I hope I don't make any mistakes here. Negative 6x squared plus 12x minus 60. Would love for this to go in nice and even, so hopefully negative 6 is the number, which is negative 6x squared plus 12x minus 60, and the remainder is 0. So that means that this polynomial, right, this polynomial factors in such a way that it's x squared minus 2x plus 10 times x squared minus x minus 6, which is x minus 3x plus 2. And if you want, you can leave this here. Now, if they say linear factors, this doesn't count as your answer, right? And it says find the zeros, so we know that this is a 0, right? We know that that's a 0. And then we know that another 0 would be x equals 3, x equals negative 2, and x equals 1 minus 3i. So x equals 1 plus 3i. These are the zeros. If it says linear factors, you got to break this down like that into those two linear factors. If it doesn't say linear factors, this is a quadratic factor. Okay, so that is pretty good. I think we're just about ready to wrap. I'm just going to show you a checkpoint, and then we may need to pause here. So here's a checkpoint. I would pause the video and give that a try. And then I'm just going to talk a little bit through example 9, just so that you are kind of ready for it. So this is a situation where you're going to basically use the rational root theorem for example 9, get something, you're going to peel it down, you're going to get a couple roots, so you're going to break it down. Then you might still have a cubic, because this is the fifth power. This is kind of where this is kind of the end, the finish line. You'll then have a cubic, you'll factor that by grouping. You may still even be able to factor that and get some complex roots. So you're going to have 5 roots from this thing. Some are complex or imaginary, and some are regular. So that's something we may or may not get into in a video, or maybe not. And then this is another type of problem that I know I'm going to ask you this at some point. So let's say I want you to find all the zeros of this, find its linear factorization, but this is a factor. Okay, so that's maybe a hint. So it would be good to try those if you have time, but perhaps we'll make another video. We'll see you in that next video. Peace.